Yes, hello everyone, welcome on YourPedia platform. I hope you all are fine and your preparation for GATE examination is going very well. Guys, as you all know, we have launched this NPTEL question module, and through this module we are practicing so many concepts, questions, okay, to prepare for upcoming GATE examination. Today I am here in front of you with the two questions from NPTEL assignment, guys. So you know guys, this particular book, NPTEL assignment book, we have launched, okay, and this is available. If you want to purchase this, you can go to our website. So I'm going to solve two questions from this particular NPTEL assignment book only, guys. So if you go to chapter 2, chapter 2.1, you will find these two questions over there. I'm going to put question in front of you. Chapter 2.1, Basic Thermodynamics 1, okay, and in that I'm going to solve question number 74 and question number 50, okay. So if you are having this book, you can refer to those questions. Otherwise, here I'm going to put the question in front of you. So let me put it here. First, question number 74 of that NPTEL assignment booklet, okay. So please read the question and try to solve with me. So guys, what he is asking in this question, let us read this first. So what he has given you, just give me a second, fine, yes. So there is a piston cylinder device initially contain 0.5 meter cube of nitrogen gas at 400 kilopascal and 27 degrees Celsius. An electric heater within the device is turned on and is allowed to pass a current of 2 ampere 4 times T from a voltage source 120 volt. Okay, so 120 is the voltage supply, 2 ampere is the current, okay, and it is allowed to run for a time T. Okay, nitrogen expands at constant pressure by the resistance heater. So the expansion process can be considered as a constant pressure expansion, and the heat lost is 5 kilojoule occur during the process. So 5 kilojoule is the heat lost by the system. So the piston cylinder device is losing 5 kilojoule of the heat. If the temperature rises by 30 degrees Celsius, then determine the time used for heating. Use Cp of nitrogen as 1.039 and R as this. So question is very simple, guys. You know, if you refer to this particular data, you will find this actually the piston cylinder arrangement is nothing but a kind of what, non-flow system, closed system. Okay, so this is this kind of arrangement we are having. Okay, so okay, let me take it like this only. So this kind of arrangement. So this is a piston cylinder arrangement, guys. Piston cylinder arrangement, something like this, in which the mass, it contains, how much is the volume, guys? The volume is 0.5 meter cube. This is the volume. It is better to write it as V1 because this is the volume before the expansion. Okay, and the pressure is what, 400 kilopascal. Temperature T1 is 27 degrees Celsius, so you can write it as 300 Kelvin. Fine. So there is a resistant heater attached, something like this. So you can consider here a kind of resistive heater in which you are supplying some current of 2 ampere passed for a time T that we don't know the how much time we run that particular system. Actually, he asked you how much is the time, how much time you run that particular heater. Voltage is given to us 120 volt. So this entire data is given to us. So now due to this, because you are giving some work, electric work you are doing on the system, it is losing some heat also. Q lost is nothing but minus 5 kilojoule because it is a heat lost by the system. So it will be minus heat added to the system is positive, heat rejected by the system is negative, work done by the system is positive and work done on the system is negative. So this is actually the electrical work which you are doing on the system, which is nothing but VIT. Vi is the power, and if you multiply that with T, you will get the work input, electrical work input, but that will be negative. Okay, so the question is very simple. You need to write the energy balance to get the answer. And the energy balance, you know, from which law we are getting? Second law or first law? From first law of thermodynamics we are going to get the energy balance, because according to first law of thermodynamics we know we cannot create energy, we cannot destroy energy, the total energy is going to remain conserved. Okay, so you need to write the first law of thermodynamics for a non-flow system, because it is a case of what, a piston cylinder arrangement. So mass is not crossing the boundary and the heat is transferring. So it is a case of non-flow or what you can say closed system. So if you know about that basic equation, first law of thermodynamics for a closed system, and if you go with the basic sign convention of heat and work, easily you will get the answer. So the temperature rises, the change in temperature is given to us, delta T is nothing but 30 degrees Celsius. So you can write it here, the T2 final temperature is nothing but 330 Kelvin guys. So this is the initial temperature 300 Kelvin, the final temperature will be 330 Kelvin because the temperature is rises by 30 degrees Celsius. So Cp is given to you, Cp of the nitrogen is this, Cv R is given to you, and Cv also you know, because if you know the R, so Cp minus Cv is nothing but R. So Cv you will get by subtracting R from Cp. So this relation also you can use, because nitrogen is an ideal gas, you can go with this relation Cp minus Cv equal to R. Okay, so Cv is also known to us. Now this time you need to find out. I hope this question is very clear. Please try with this data guys. Guys, whenever you are getting some question in GATE examination, first you need to extract the basic information, important information from the data which is given to you. Okay, so this is the data which he has provided, and you need to convert it into some useful information. You need to write all those important stuff, and then you need to start solving that numerical. Now let me put it here. Let me write it here. The first law of thermodynamics. So you know guys, dq equal to du plus dw. This is the first law of thermodynamics. First law of thermodynamics for a closed system. For a closed system. Okay, किसके लिए? Obviously for a process. First law of thermodynamics for a process in a closed system. ये process के लिए लिख रहे हैं बच्चों. This is for a process in a closed system. Okay. Now, if you write all those terms, guys, how much is dq? Dq is nothing but minus 5 kilojoule. So I'm going to write all these energies term in kilojoule only. So this is minus 5 kilojoule. How much is du? Can I write it as mcv dt? Yes, I can write it like this, mcv dt. How much is w work? There are two type of work, guys. One is the boundary work or expansion work. Boundary work because boundaries are going to expand. The expansion will be constant pressure. So one, there is a boundary work that will be positive because boundaries are going to expand, and when closed system boundaries are expanding, we are going to get the positive work. Okay. Next there will be electric work which will be negative. Okay, these are the two work that you need to think and you need to write, because then only you are going to get the answer. Now let me further write these terms. Minus 5 equal to, how much is mass, guys? Mass. How much is the mass present in the piston cylinder arrangement initially, because mass is same. So how you will find out the mass, guys? You know, ideal gas equation, PV equal to mRT. So mass is nothing but PV by RT. So how much is pressure, guys? Initial pressure 400 kilopascal. How much is volume? 0.5 meter cube. How much is temperature? 300 Kelvin. R also you know 0.297. Putting all these things you will get the mass. So 400 kilopascal, 0.5. Okay, 0.297, let me check the value, exact value, and this is 300 Kelvin. So solving this, 0.297, right, 0.297. So all these values I have taken from the data which is provided, which is given to us. Pressure 400 kilopascal, volume 0.5 meter cube, R characteristic gas constant 0.297, and the temperature is 300 Kelvin. Solving this you will get the mass, guys. इसको solve करोगे तो आपके पास mass आ जाएगा. Fine. So that value of the mass you need to put it here. वो value आपको यहाँ पे रखना पड़ेगा, otherwise let me write it here, 400 into 0.5 divide by 0.297 into 300. Okay, and what will be CV, guys? CV will be R, this Cp minus R. So Cp is 1.039. So 1.039 minus this R 0.297. This will be CV. How much is dt, guys? The change in temperature is 30. The initial temperature is 300 Kelvin. The final temperature is 330 Kelvin. So the change in temperature is 30. So this is what? This is change in internal energy plus the boundary work. Boundary work will be PdV. Okay. Minus electrical work. Electrical work will be the voltage into current into time. Divide by 1000, guys. Divide by 1000. Why? Because, guys, this is in kilojoule. This is also we are taking in kilojoule. How? You can say, sir, this CV we are taking kilojoule per kg Kelvin. What will be the unit of CV, guys? Kilojoule per kg Kelvin. So mass kg will cancel out, here Kelvin will cancel out. You will get the change in internal energy in kilojoule only, guys. So this is kilojoule. This is also in kilojoule. This PdV, pressure we are going to take in kilopascal only. Pressure is constant, which is 400 kilopascal. Initial volume is known to us. Final volume also you will get if you use the basic relationship pressure constant at pressure constant V1 by T1, that is equal to V2 by T2. So it means V2 equal to V1 into T2 by T1. Okay, so the final volume will be V1 0.5 into T2, which is 330, T1 is this, so you will get the V2. So we know the change in volume, we know the final volume, we know the initial volume, easily you will get the change in volume. Pressure also we know. So pressure we are going to take in kilopascal, so that we will get this term also in kilojoule. So this is in kilojoule, this is in kilojoule, this is also in kilojoule. So you need to convert this electrical work also in kilojoule. So VI into T you need to divide it by 1000, otherwise you will not get the answer. So let me further put all these things here so that we will get the final answer. So minus 5 equal to 400 into 0.5 divided by 0.297 into 300, 1.039. Okay, let me write the some kind of data final value which we are going to get after solving this, so that you will be able to match your answers. Just give me a second, guys. So let me put it here, the value which you are going to get. Yes. So guys, solving this, we will get the value 49.963. 49.9663. Okay. So this is the value we are going to get, plus pressure is 400 into 0.55 minus 0.5. So solving this you will get V2 equal to 0.55 meter cube. So the final volume will come out 0.55 meter cube. So you can use this data here, okay, and you can check it here. Fine. Chaliye. Plus minus voltage is what? 120, current is 2, time is T, divided by 1000. So there is only one unknown, guys, in this equation. There is only one unknown. This is minus 5 equal to minus 14, this plus 49.963. Solving this you will get a value close to 20. Okay, इसको अगर आप solve करोगे you will get a value 20 and minus this. Okay, so guys, if you solve this entire thing you will get the time 312.359 second. And if you convert this into minute, you will get the answer close to 5.2 minute. Okay, the final answer will be 5.2 minute. So now if you check it here, the options which are given to us, option A 5 minute, option B 15 minute, option C 25 minute and option D 30 minute. So very correctly you will be able to answer this question, guys. The right answer will be option A 5 minute. Okay, so I hope, guys, this question is clear to all of you. Basic question related to thermodynamics, first law of thermodynamics, but yes, you need to have some understanding of the equation and how to utilize that basic equation, first law of thermodynamics equation, for a closed system to solve these kind of question, guys. Okay, so you need to consider all different kind of works. Here we consider the electrical work, the expansion work also, heat lost, that also we have considered. Fine, guys. So if you got the answer, it's very good. Otherwise you need to check it here, you need to check where you are making some kind of mistake. Let us move to next question, guys. Second question, which is the question number 50 in that NPTEL booklet. Okay, so if you are having that booklet, you can refer to question number 50. So there is a rigid tank. There is a rigid tank containing 5 kg of air at atmospheric pressure 317 degrees Celsius. The air is cooled to the surrounding temperature of 17 degrees Celsius. Assume constant specific heat at 300 Kelvin. Determine the entropy change of the air in the tank during the process and the net entropy change of the universe due to this process. The specific heat of air are given to you. Cp is equal to 0.17 kilojoule per kg Kelvin. So he is asking you two things, guys. The entropy change of the air due to that kind of cooling process of the air. The air is there in a rigid tank, okay, kind of compressor tank which we are having. So air is at a high pressure, high temperature in that tank. No, pressure is not high, pressure is atmospheric only, he has given, but the temperature is high. The temperature is 317, the atmospheric temperature is 17. Obviously due to that temperature difference, air is going to lose the heat, so entropy of the air is going to decrease. Okay, entropy change of the air will be negative. So obviously A, B will not be the correct answer. Out of C and D you are going to get the answer because entropy of the air is going to decrease. And net entropy change means the entropy change of universe, which is nothing but entropy generation, okay, or this is nothing but net entropy change. So this is known as what? This is known as entropy change of system plus entropy change of surrounding. So guys, if you are collectively taking the change in entropy of system plus surrounding, that is going to give us the entropy change, net entropy change, or which is also known as entropy generation, or you can refer that particular term as entropy change of the universe. And what do you understand by entropy change of system, guys? Entropy change of system means the air, entropy change of air, okay, and the surrounding you can treat it as a thermal energy reservoir, okay, large energy reservoir. So entropy change of surrounding means thermal energy reservoir will be what? Q divided by temperature of surrounding. So what is Q? Q is the heat which that air is dumping, the system is dumping, or system is losing into the surrounding. So that Q is the heat lost divided by temperature of the surrounding. So this will be the entropy change of surrounding, and definitely that will come out positive. Why? Because you are giving heat, you are dumping some heat into the surrounding. So entropy change of the surrounding will be positive, but the air is losing heat, so air temperature is going to come down, and that's why the change in entropy of the air will be negative. But collective entropy will always be positive. That is second law of thermodynamics. The total entropy change of the system plus surrounding, the net entropy change can never be negative. Okay, system entropy can be positive, negative. Individually surrounding entropy can be positive, negative. It depends whether you are dumping heat or whether you are taking heat from the surrounding. But the collective entropy or entropy change of the universe will always be positive. Entropy change of the universe can never decrease. Entropy of the universe is keep on increasing. Okay, that is second law of thermodynamics, principle of increasing entropy of the universe. Okay, I hope you know the entropy change of universe or a isolated system will be always greater than equal to 0. It can never be negative. That is second law of thermodynamics. Okay, now let us solve this question, guys. You can note it down, this entire data, and let us solve this problem. Very typical GATE problem, guys. Many times these kind of questions were asked in GATE. Okay, so you need to practice these kind of questions also. So there is a rigid tank, something like this. There is a rigid tank. Okay, rigid tank means, rigid tank का मतलब क्या है? The volume is constant volume. Okay, the boundaries cannot expand or contract. The volumes are what? Volume is same, constant. Now how much is the data? What data he has provided you? The mass is 5 kg. So you can write it here. The mass of air 5 kg air. Pressure कितना है? P atmospheric. Temperature कितना है? 317 degree Celsius. T atmospheric. Atmospheric temperature is what? I think this is 17 degree Celsius. Okay. So now we need to find out the entropy change of air and net entropy change of the universe. Let me write it here, guys. Entropy change of air. So guys, air is an ideal gas, and I hope you know the basic formula to calculate the entropy change of ideal gas. So guys, here the volume is constant, temperature change is given to us. So very correctly you can use this formula, mCv ln T final means T2 by T1, T final by T1 plus R ln V2 by V1. Okay. So mCv ln T2 by T1 plus R ln V2 by V1. Okay, this is natural logarithm. So this term will be 0. Why? Because volume is constant, V2 equal to V1, and log of 1 will be 0. So this term will be 0 because volume is constant. So now if you put it here, the mass which is 5, Cv which is 0.718, ln T final will be what? 17, so it is 290. T initial is 317, so 370 plus 273. 273 कितना आ जाएगा? It will be 590. Okay, 590. So 5 into 0.718 ln 290 divided by 590, and yes, you are going to get this value negative. Why? Because air is going to cool and its entropy is going to decrease. If you solve this, you will get the answer minus 0.2549 kilojoule per kg, kilojoule per Kelvin, guys. So this is the entropy change of what? This is the entropy change of air. Entropy change of air. Now if you want to find out the entropy change of what? Universe. So entropy change of universe is nothing but entropy change of air system plus entropy change of surrounding. So this is what, this is coming out negative, this is coming out negative. Okay, note this guys, actually this value will come out 2.549. Okay, so let me write it here. This value will come out minus 2.549. okay, kilojoule per Kelvin. चलिए, so minus 2.549 minus 2.549 plus how much is the heat lost? Q lost divided by temperature of the surrounding. Okay, so guys, how much is Q lost? How much heat the air is losing? Can I write it as mCV dt because the volume is constant? So at constant volume, how we can write the heat transfer? So at constant volume, heat transfer for an ideal gas is nothing but the change in internal energy. And how we can write the change in internal energy for an air gas, ideal gas? This is mCV dt. You know guys, for a constant volume process, isochoric process, the heat transfer will be change in internal energy, and that will be mCV dt. So now how much is mass guys? Mass is 5. How much is CV? 0.718. And how much is dt guys? The change in temperature will be what? 300 Kelvin. 300. Okay, Kelvin or degree Celsius, because in both the cases difference will be same. So this is the initial temperature, this is the final temperature. So the change in temperature is 300. Solving this, you will get the Q. Okay, इसको solve करके बच्चों you will get the amount of Q. Fine. So now if you put all these values here in this equation, you will get entropy change of universe equal to minus 2.549 plus this value Q, which you are going to get from this equation, Q lost, divided by the surrounding temperature, which is 17 degrees Celsius. This is the surrounding temperature or atmospheric temperature, 290. Okay, so solving this guys, you will get the entropy change of universe, which will come out, okay, which will come out 1.1647. 1.1647 kilojoule per Kelvin. Okay, so if you solve for the value of Q, you are going to get a value, let me put it here guys, you will get a value 1077 kilojoule. Okay, so 1077 kilojoule. So you can check your calculation. So Q lost will come out 1077 kilojoule. Dividing by 290, you will get the entropy change of surrounding also. But individually, he has not asked you the entropy change of surrounding. He asked you the entropy change of system, means this, and the net entropy change means the system plus surrounding, which will come out positive, obviously, 1.1647. Okay, so if you match the answers, the entropy change of air will be minus 2.55 kilojoule per Kelvin. Okay, it is we got the answer minus 2.549, which is very close to minus 2.55. Okay, and this will be 1.1647. So the right answer for this question will be what guys? The right answer will be D. Okay, so D will be the correct answer. This is the entropy change of air. Okay, and this is the entropy change of universe, means both system and surrounding. Okay, so very typical gate level question guys, we have solved. I hope you got the idea about these two questions, and yes, this time you need to be ready with all basic concepts guys, because number is going on, and we are going to get, you need to appear in the GATE examination in the month of January only. So this time you need to be ready with all those concepts. On daily basis, weekly basis, you need to revise each and every subject. Okay. Chaliye, so that's why I'm picking the random question. Again we will meet and we will solve some more questions from this particular NPTEL assignment book. I hope this will help you in your GATE examination. Thank you, keep revising, best of luck for your exam. Thank you.